All right, 4.5 part 1, or notes are going to be on your own. I don't have the, or I don't like the pre-made ones, so we're going to do these on our own. And what this is we're going to start looking at the graphs of our trig functions. Specifically, we're going to look at sine and cosine today. So when we started with, we had a unit circle where we had our points 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Well, what we're going to do is we're going to take the circle, and what we're going to do is we're going to spread it out laterally instead of putting it on a circle. So what we're going to do is we're going to match up that this, and we're looking at the sine first. So here I have a high value of 1 and a low value of negative 1, just like I do on my picture. And we talked about this with the domain and range before in the previous sections, where it's always from positive 1 to negative 1. And I look at what is the sine of 0. Well, the sine of 0, the y value of 0, is 0. All right. Then I'm going to come out here to 90 degrees, 180, 270, 360, which is also the same as pi over 2, pi, 3 pi over 2, and 2 pi. Well, at 90 degrees, I get a sine value of 1, 0 at 180 or pi, 3 pi over 2 is negative 1, and then back at 2 pi is 0. So we see that the lateral graph of the sine wave is this curved shape that starts at 0, maximizes at 1, minimizes at negative 1, and ends back at 0. Well, whether we're talking about sine or cosine, we're going to be able to shift and move, and we need to be able to find different pieces of information regarding this. So in general, we are going to be looking at y equals a, and I'm focusing on sine here, so sine b of x. A represents amplitude. Now, amplitude is how high or low the graph goes. So on this one, this is y equals sine x. The A is 1 because it went up 1 and down 1. The other thing with amplitude, because we're talking about a distance, how high and low does it go, it is always positive. So it's the absolute value of A, because if there was a negative number out here, I'll talk about what that does, but it's going to be that number. It's not going to be the negative of it. It's always the absolute value of it. So here, y equals sine of x, the high and low is A, which in this case is a 1. B is the period. The period is the number of waves. So here is one sine wave. The number of waves you see in one full cycle. We have a formula in order to do that, and it's 2 pi over b. That tells you how to find period. Or if you're in degrees, it's 360 over b. So if I look at this, this is one wave. So if I look over here, there's a 1 in front of the x, so that's where my b is. I see one wave in a full cycle of 0 to 2 pi. Okay, so let's just look at quick sketches of if I had y is 5 sine of 3x. I would have my amplitude is 5, so I would be going 1, 2, 3, 4, 5, 1, 2, 3, 4, -5. Alright, I'm going to see 3 waves in 360 degrees or in 2 pi. So how long is each wave? In order to find the period of each wave, it's 2 pi over 3 or 360 over 3. So 2 pi over 3 or 120 degrees is how long each period is. One wave is going to be that long. So that means I'm going to split this up into 120, 240, 360. And what's unique about a sine wave is that it's always going to have this same kind of pattern. The beginning and end is always the same. The middle is at 0 as well. The highs and lows are halfway in between. So if I look at 160, the middle is 60. I know it's going to begin, middle, and end at those locations. Halfway between that is its height. Halfway between that is its low. There's one wave of the sine. I'm going to have 3 of them in this whole thing. So there's a half, and then half, half. Half up, the other half down, and continue. So there's my second wave. Half of 240, 360, and then halfway between those is going up, going down, and there's our 3 waves. And I know my measurements of them. And I do need to label them, and I do need to label them with radians or degrees unless directions specifically tell me which one I need. It doesn't really matter. Okay, let's look at another one. Y equals -2 sine of x. Okay, so this is that negative that I told you about. What happens with this is that it means it starts in the opposite direction. We know our amplitude is 2. That's how high and low it's going to go. And we know our period is 1, or our b is 1. The period is going to be 2 pi. Alright, so when I make my picture, I know I'm going high and low, +2, -2. I know that I'm only going to see one wave in 2 pi or 360. So I'm going to cut that up into 0, middle is 180, end is 360, or pi and 2 pi. Middle is up, oh, sorry, not true. Middle is down, middle is up. Because we're starting in opposite direction, we go downwards. So basically what that negative does is exactly what the negative has done on everything we've done, is that it reflects over the x and y axes when we throw in our negatives. So that's why it started downwards instead of the traditional sine going upwards. It started from the negative. Okay, let's try one more. Y equals sine 1/2 x. So with this one, our amplitude is 1, our b is 1/2, so that means our period is 2 pi over 1/2, which means 4 pi. I'm only going to see half of my wave in a 2 pi frame. If I want to see a whole one, I would have to go out to 4 pi, and we want to see a whole one. So I know my high-low is 1 and -1. I know my beginning, my middle, my ends are all at 0. I know I'm going to 0 to see a whole pi. I have to go to 4 pi, which means my middle is at 2 pi, pi, and 3 pi. It's positive, so I start up, and there I go. If I was only going to look at a one cycle, a 2 pi graph, I would only see half of my picture. If I was just doing up to 2 pi, because that's what it says. I'm seeing half of a cycle in a 2 pi completion. So now, in order to see a whole cycle, I would have to draw it out to 4 pi. All right, cosine, same thing. All right, let's start with the circle. And now we have our points. That means when I look at y, a cosine bx, which in general is just y cosine of x, I'm going to be going from -1 to +1. The x value at 0 is 1. Let's put our values right. This is 1, 0. And 0. Okay. So when we do this, we have the cosine value at 0 is 1. At pi over 2 or 90 degrees, the cosine value is 0. At pi or 180, the cosine value or the x value is -1. At 3 pi over 2 or 270, the cosine value, the x value is 0. And then at 2 pi, the cosine value or the x value is 1. All right, so now that we connect these dots, we get a wave that starts up and ends up. And that's going to be what happens with the cosine. It starts up and ends up. Unlike the sine wave that starts down and ends down or at zeros, we're going to be starting at our amplitude. Because again, A means amplitude, B is our period. It has the same representation that as if it was with a sine. Everything works exactly the same way. So let's look at those same kind of examples. 5 cosine of 3x. How do we graph this picture? First of all, we need to know the amplitude is 5. We need to know the b is 3. Therefore, the period is 2 pi over 3, or if we're in degrees, 120 degrees. So here I have 5 and -5 as my amplitudes. I know I'm going to want to see 3 waves in a 2 pi extension, or I'm going to see 1 wave in 120. So if I come out here to 120, 240, 360. I know that this is, in this first area, I'm going to see 1 cosine, 2 cosines, 3 cosines. I do need to come up with those middle values. So the middle here is 60, the middle is 30, the middle is 90. I'm going to start up, go through, come down, go through, end up. So that's one sine wave. And it's going to repeat that exact process. Halfway, half, half. And repeat. Halfway, half, half. And repeat. So there's our cosine wave. Same thing is going to happen if I do a negative. So in this case, my amplitude is 2, my B is 1, which means my period is 2 pi or 360. The only thing is that that negative tells me I'm going to start at the down or the -2 spot. So here's 2, here's -2. Instead of starting up, I'm starting down. I know it's one of them in 360, so there's my end. There's my middle, there's my middle, there's my middle. I start where I end, so if I started down, I'm ending down. And those are my points. And the last one, cosine 1/2. My amplitude is 1, my B is 1/2. That means my period is 4 pi. So if I'm out here at 4 pi, 2 pi, 1 pi, 3 pi, 1, -1, and I'm just starting up, going through, coming down, going through, ending up. And keep in mind, if I only saw 2 pi of this, if I only saw one circle of it, I'd only be seeing half of my cosine wave. The second thing you need to do is you need to be able to go the other direction. If I gave you this picture, would you be able to give me the equation? Can you look at it and go, okay, my amplitude, I know what my A is. In 2 pi, I only see half of it, therefore it's half x. If I gave you, one of the other ones, it starts at 0, or it starts and ends in the middle all the same, that's a sine wave. Could you tell me, oh, it went high and low 5, and I see 3 of them in a 2 pi. So be able to go from a graph to a picture as well. So that's part 1 of your 4.5 note.